This is 13C in our unit on electrostatics. Let's see here. All right, so just for any of the announcements on assignments or anything, just watch the introductory video. The big question for today is, why does a balloon stick to hair? So these are the weekly plan. You can see here, it's just sort of a loose schedule, so we have room for everything that we need. But there is always going to be those three activities: the lab activity, the homework, and that notebook check. There are codes in the video. The one's written, one is verbal. Each code will be three numbers. You'll need all the codes in order to move on with that homework assignment. So for the notes, just write what is in green. You'll need these in the notebook check. And the 13C written code is up on the screen. I would recommend writing this down somewhere. So first we're going to do the Revenge of the Pith lab. So this is a lab where we just rub the PVC rod with fur and see what happens to the little pith balls that are hanging. Now, that brings us to electrostatics. So recall that protons and neutrons are held together by the strong force, while the electrons are bound to the atom by the much weaker electromagnetic force. This means it is a lot easier for the electron to be stripped away from the atom. Now, this is going to be the whole idea behind electrostatics. For all of the problems that will be given, like in all of these units, just ask these questions. What do like charges do? What do opposite charges do to each other? And what will the electrons do, right? So just think about what the electrons will do. So electrical conductors allow the flow of electricity through them. Electrical insulators do not allow the flow of electricity through them. So we'll sort of skip through that. And just like a history of that, Ben Franklin was actually the person that came up with the terms positive and negative charges. Back then, they thought electricity was like an invisible fluid that flowed from one state to the other, right? So it's just a word, though. You could have called them anything. All right. So that led him to an important conclusion. This is the law of conservation of electrical charge. Charge can neither be created nor destroyed. Charge can only be transferred from one place to another. The total amount of charge in the universe is fixed. The fundamental rule at the base of all electrical phenomena is that like charges repel and unlike charges attract. So, because electrons are easier to move from the atom than protons, when you rub one material against the other, in some, the electrons get transferred from one object to the next. Protons do not get transferred because they're held together by the strong force. If the object gains electrons, then it becomes negatively charged. If the object loses electrons, it becomes positively charged. Now, all that's been done is for the charge to have been transferred. We do not gain or lose any charge. The total amount of charge remains fixed. So why does a balloon stick to hair? So let's talk about different types of charging and polarization. Polarization is the process of separating opposite charges within an object. The polarization process always involves the use of a charged object to induce electron movement or electron rearrangement. Now, the electrons do not get transferred from object to another during polarization. So you can look at that during this simulation. Now let's look at charging by friction. So charging by friction is the process of transferring electrons by rubbing objects together. Now recall the total amount of charge does not change. What changes is on the object is more electrons. So you can see here that just like we did with that the fur and the rod, see here that those electrons get transferred when they're being rubbed together. So now this brings us to charging by contact, or as it's also seen, charging by conduction. So charging by contact is a process of giving one object a net electric charge by placing it in contact with another object that is already charged. So you can see off to the right that those electrons, that is negatively charged, and what's happening is those electrons are trying to get away from each other, right? Because they're the same charge, and once you touch that object, you have given those electrons a path to spread out. So charging by induction. Charging by induction is the process of bringing a charged object near but not touching a neutral object. The presence of a charged object near a neutral conductor will force or induce electrons with the conductor to move. Then the object is grounded to charge the object. So you can see off to the right, it's just like polarization. That's the first step. But then what these graphics don't show is this last part down here that's shown is that it's grounded, or there's a way to take that charge away. Or depending on the charge, those electrons might go from the ground to that object. So let's talk about grounding then. Grounding is the process of transferring any excess charge of a charged object to another object of substantial size, mostly Earth. provides a pathway for electrons to or from Earth. So let's take a look what that means. Right, if an object is positively charged, grounding it will provide a pathway for electrons toward the object for it to become neutral. If an object is negatively charged, grounding it will provide a pathway for electrons away from the object for it to become neutral. Now, lightning is a form of grounding. So there's an excess charge in the sky, and well, it once that charge builds up enough, yeah, you provide a way. It's just through the air, and it can ground that cloud, releasing that excess charge. All right, so what determines which object gains or loses electrons when charging by friction? So that's what we're going to do, the static cling lab. All right, so what does that is the triboelectric series. So the triboelectric series is a list that ranks materials according to their affinity or love towards electrons. So some objects want electrons more than others. Charging by friction is also called the triboelectric charging. So what it means is that different materials want electrons more or less than other materials. And I put that in quotes because objects don't want anything. The materials toward the bottom of the list have a larger affinity or love for electrons, and then they have the tendency to go negative. The materials towards the top of the list have a smaller affinity or love of electrons, and they have a tendency to go positive, to give up those electrons. Now, if two objects are being rubbed together, the material lower on the list will gain some of those electrons and become negative. And at this time, I'll go ahead and give you the 13C. Verbal code is 367. I say that again, the verbal code is 367. All right, so these are the links for today. You can see there's a lot of extra videos that you could watch, and that will help you understand this material a little bit better. Also, there are some resources in the labs and demos. And as always, I leave you with this final thought. There's just too much unknown in the universe to take a break from learning. Get out there and question everything.